Hello students, welcome you once again back to GK's maths classes. Okay, this will be my concluding video in matrix where we talk about transpose of a matrix and problems related to transpose of a matrix. So with that we covered the entire concept of matrix. Next video I will be putting on determinants. Okay, I hope you have gone through matrix multiplication and problems related to that introduction of matrix in my previous video. Okay, and I kindly request you to subscribe to my channel and also to press the bell icon to get notifications on all videos that we post. I hope till now whatever video we have posted and in future you will be benefited and it will be useful for you. Okay, shall we continue now? Now let's see. Now, what is transpose of a matrix? Transpose of a matrix. Transpose of a matrix is nothing but it's an operation. What do? You don't do addition, you don't do subtraction, you don't do multiplication. But what exactly you do? You interchange rows and columns. For example, if I have a matrix A equal to, suppose you have A, B, C, D, E and F. What is the order of this matrix? This is 2 by 3. It has 2 rows and it has 3 columns. Correct? Now, I want to find transpose. The notation generally used in the book is A dash. A dash stands for transpose of a matrix, or some books also follow this notation of AT. This means transpose of a matrix. Now, what is transpose of a matrix? The row and columns interchange. What do you mean by row and column interchange? This becomes A, B, C, D, E and F. This process is called transpose of a matrix where the rows and columns are interchanged. Now, what is the order of this matrix? This is 3 by 2. So, clearly a 2 by 3 matrix becomes a 3 by 2 matrix. I'll give you one more example. Okay. Suppose if I have a matrix A equal to 1, 2, 3, A, B, C and alpha, beta, gamma. Now, how do I find transpose? See the notation A dash, or you can put A transpose, whatever you want. Rows and columns are interchanged. 1, 2, 3, your row become column. This process is called transpose of a matrix. This is a 3 by 3 matrix. Here there is no change in the order because it is a square matrix. Okay. I give you one more example. Suppose if you have a matrix A, B, C. It's a row matrix. It's a row matrix. Now, how do I find transpose of this? The row becomes column. So, your row matrix, which was 1 by 3, gets converted into a column matrix, which is 3 by 1. So, I hope you understood the process of transpose of a matrix. Okay. Now, there are some very, very important and very, very interesting results that you should know about matrix, about transpose. The first important result that you should know is, if I have two matrices A and B, and if I add them and I take whole transpose, it is same as A transpose plus B transpose. A plus B whole transpose is same as A transpose plus B transpose. This result is applicable even if you have a minus sign. So A minus B whole transpose is also equal to A transpose minus B transpose. So that is why I put the plus or minus. The second very, very important result where many people make mistake is, if you take product and take transpose, this is not A transpose into B transpose, but it will be B transpose into A transpose, just to facilitate multiplication. Okay. So AB transpose is A transpose into B transpose. Sorry, is B transpose into A transpose. So it is definitely not A transpose into B transpose. AB transpose is not A transpose into B transpose, but it is B transpose into A transpose. Okay. Third one, very, very obvious result. If you take transpose of a transpose, if you take A transpose, whole transpose, obviously you get back the matrix A. Correct? Okay, I hope you understood this result. Now the fourth very, very important result is A is a square matrix. You get a 1 mark, 2 mark, or 1 mark, or 2 mark, or 3 mark question from this. If A is a square matrix, okay, if A transpose is A itself, if A transpose is A itself, then A is called symmetric matrix. If A transpose is minus A, then A is called skew symmetric matrix. Okay? If A transpose is A, it is symmetric matrix. If A transpose is minus A, negative of A, then it is called skew symmetric matrix. So you should not forget these properties. These 4 properties are very useful for me to solve problems. Now let's go to the questions. I have written down the questions here. So the first question is, if A is a row matrix and B is a column matrix, I need to verify this property. You see this problem, I want to verify this property. Okay? It holds for any matrix provided the multiplication is well defined. Okay? Now let's see. First I will do A into B. What is A into B? Minus 2, 4, 5 into 1, 3, minus 6. What is the order of this matrix? It's 3 by 1. What's the order of this matrix? 1 by 3. Is it possible for me to multiply? The answer is yes, because the number of column of the first matrix is equal to number of row of the second matrix. Now what will be the order of the resultant matrix? The order of the resultant matrix will be 3 by 3, because it's number of row of the first matrix by number of column of the second matrix. Now how do I multiply? First row, first column. See, this is first row and this is first column. First row, first column. What do you get? It's only minus 2. First row, first column. Now first row, second column. First row, second column. I have to write here. So minus 2 into 3 is minus 6. Easy to multiply. First row, third column. What happens here? Minus 2 into minus 6 is 12. Finished. Now what do you do? Go to the next row. Second row, first column. What is second row, first column? 4 into 1 is 4. Second row, first column. Then second row, second column, 12. Second row, third column, minus 24. Very easy. Since it is one element, it's easy to multiply. We don't have to add. Third row, first column. What is third row, first column? 5 into 1 is 5. Third row, second column, 15. Third row, third column, minus 30. So this is my product AB. By now, I'm sure you should have understood what AB is. Now I want to find the AB whole transpose. What is that? Minus 2, minus 4, 5. Your column becomes row. Minus 6, 12, 15. Then 12 minus 24 minus 30. Call this as 1 and leave it. I am done with AB whole transpose. Now what I want to find? I want to find B transpose into A transpose. Now what is B transpose? It's a row matrix. It will become what? Column. 1, 3, minus 6. Now what is A transpose? Minus 2, 4, 5. Is it multiplication possible? Obviously, exactly like this. This is 3 by 1. This is 1 by 3. multiplication is possible, and also the order of the resultant matrix will be 3 by 3. Okay. Now, how do I multiply? First row, first column, minus 2. First row, first column. First row, second column. First row, third column, 5. Second row, first column, minus 6. Second row, first column. Okay. Second row, second column, 12. Second row, third column, 15. Third row, first column, 12. Third row, second column, minus 24. Third row, last column, what is that? Minus 30. All this is 2. Now look at 1 and 2. They are exactly the same. From 1 and 2, what do you say? AB transpose is equal to B transpose into A transpose. So I have verified this result will be true for any matrix which satisfies, of course, the multiplication property. AB transpose will be B transpose into A transpose. It cannot be A transpose into B transpose. Okay. The next one. A very, very, very important result where you can get a 4-mark question. Derivation is not important, but I've derived it for you so that you understand when I do a problem why I take certain things. Okay, we'll discuss it later. Now, what is this? What is this property? This is a very important property. Every square matrix, not all matrix, every square matrix can be uniquely expressed as, uniquely, very important. There is only one way of writing, uniquely expressed as what? Sum of symmetric and skew symmetric matrix. Then the question is, what is symmetric and skew symmetric? Suddenly, these new words are coming. I already told you that if I take a matrix and take transpose, if I get back the same matrix, it is called symmetric. If I take a matrix and take transpose, and if I get negative of that matrix, it is called skew symmetric. Okay? So that is the idea. So let us see. Now, let me take a matrix. I have already written it so that we can save time. I have taken matrix A, which is a square matrix. Now, what I do, I write A as 2A by 2. Obviously, multiply and divide by 2. Now, what do you do? Write 2A as A plus A. Okay. Now, the next step is you add A transpose and you subtract A transpose. Add and subtract A transpose. Then what do? You split this. So you get A plus A transpose by 2, A minus A transpose by 2. Then what I do? I call this matrix as P and I call this matrix as Q. I call this as P and I call this as Q, and I have written here very clearly. Now what do? You take this P and take transpose. So when you take transpose, you get A plus A transpose, the whole transpose. Now by this result, look at this result. A plus B transpose is A transpose plus B transpose. The transpose gets distributed. So similarly, here what happens? A transpose plus A transpose of transpose, correct? You have to look at this as A. You have to imagine this is like your A and this is like your B. So A plus B transpose is A transpose plus B transpose. Okay. Now what happens? Now A transpose is A transpose, but you know A transpose of transpose is A. Now you have got P transpose is A plus A transpose by 2, which is nothing but P. But you know, if I take a matrix and take transpose, and if I get back the same matrix, then you say that matrix is symmetric. So you can say P is symmetric. So this matrix is a symmetric matrix. Now I take Q, A minus A transpose by 2. Take transpose on both sides. So A minus A transpose whole transpose will be A transpose minus of A transpose of transpose. Remember I told you A minus B transpose is A transpose minus B transpose. A minus B transpose is A transpose minus B transpose. I'm applying the same rule here. So this is A transpose. A transpose of transpose is A. Now what do you get? Take minus outside. So you get A minus A transpose by 2. But A minus A transpose by 2 is Q. So you have proved that Q transpose is minus Q. If you get Q transpose is minus Q, then Q is what type of matrix? It's a skew symmetric matrix. So this is skew symmetric. So what have we proved? You have expressed your matrix A. What matrix? Square matrix A as sum of symmetric and skew symmetric matrix. Okay. Uniqueness I am not verifying, because since you know the result, the derivation of the result is not important, so I am not going to derive it. So I hope this derivation is clear, because I need this derivation, because when I define what P and Q is, it should not be out of the box. It should not be a very random way of writing. So now with this process, I'm sure you will understand why I choose P as A plus A transpose by 2 and why I choose Q as A minus A transpose by 2. Okay. Now let's do a problem related to this. This type of question is very, very important. This is an NCRT. I have taken this question from NCRT. Express a matrix A as sum of symmetric and skew symmetric matrix. The entire process is very important. Okay. Now what do you do? First you find A transpose. What is A transpose? 6 minus 2, 2, correct? I think I should have taken some other example, because this is itself is symmetric. Okay, I'll take some other example. I'm sorry. I'll take 3, 2, 1, minus 1, 5, 6, minus 2, minus 3, 1. I've taken some other example. So what is this? 3, this is not NCRT, the numbers are different. 3 minus 1 minus 2, then 2, 5 minus 3, 1, 6, 1. I have taken transpose. This is A, this is A transpose. I hope I have not made any mistake. Yes, it's perfect. Now what do? You find out what P is. If I have not done the derivation, I don't know what P is. Now I know P is nothing but A plus A transpose by 2. Correct? Now what is A plus A transpose? Half of, add A plus A transpose. What is 3 plus 3? 6. Addition of matrix. 2 minus 1, 1. 1 minus 2, minus 1. Correct? 2 minus 1, 1. 5 plus 5, 10. I'm just adding. Okay? Minus 3, 6, 3. 1 minus 2, minus 1. 6 minus 3, 3. 1 plus 1, 2. Just normal addition. Now what do? Take transpose for this. What is P transpose? 6, 1 minus 1, 1, 10, 3, minus 1, 3, 2. And if you notice this carefully, this is nothing but P. So you have proved that P, this matrix P, okay, which is half of 6, I will not waste my time, P is symmetric. That's done, job done about symmetry. Now I want to find skew symmetry. I'll take Q. What is Q? By now you should know that it is A minus A transpose by 2. Otherwise refer to the previous slide, you will get it. Now what is A minus A transpose? Half of A minus A transpose. What is 3 minus 3? 0. 2 minus of minus 1? 3. 1 minus of minus 2? 3. Minus 1 minus 2 minus 3. 5 minus 5? 0. 6 minus of minus 3? 9. Minus 2 minus 1? Minus 3. Minus 3 minus 6? Minus 9. 1 minus 1? 0. Now I'll take Q transpose. What is Q transpose? 0 minus 3 minus 3. 3, 0 minus 9. 3, 9, 0. Now what do? From this entire matrix, take minus sign. Remember scalar multiplication. Here the scalar is minus 1. When I take minus outside, what do I get? 0, 0, 3, 3, minus 3, 0, 9, and minus 3, minus 9, 0. And clearly you see this is nothing but q. But since there's a minus sign outside, it is minus q. So what have we proved? That q is skew symmetric. So you have proved P is symmetric, you have proved Q is Q symmetric. Now what do? The last step, you add P and Q, which is half of, what is P? P is 6, 1 minus 1, 1, 10, 3, minus 1, 3, 2. And what is Q? Half of, what is Q? 0, 3, 3, minus 3, 0, 9, minus 3, minus 9, 0. Now add them. Half is common in both the matrix. I'll keep it outside. 6 plus 0, 6. 1 plus 3, 4. Minus 1 plus 3, 2. 1 minus 3, minus 2. 10 plus 0, 10. 3 plus 9, 12. Minus 1 minus 3, minus 4. 3 minus 9, minus 6. 2 plus 0, 2. Now divide by 2. Scalar multiplication. 3, 2, 1. Minus 1, 5, 6. Minus 2, minus 3, 1. And this happens to be my A. So what have you done? You have expressed the matrix A as sum of symmetric and skew symmetric matrix. This entire process is very, very important. Definitely this type of question comes for 1 mark or 2 marks. Mostly it will come for 2 marks or it can come for 3 marks. Okay. This will not come for 1 mark. This is lengthy sum. Okay. Now I have done for 3 by 3. Let me do it for 2 by 2. So just for completion. It's an NCERT question. Now before I go to that sum, I want to talk something very important. Now look at the symmetric matrix. Here my symmetric matrix is P, correct? Now what is so special about symmetric matrix? If you see, this is like, look at the diagonal. This acts like a mirror. It acts like a mirror. And you can see the elements. If this is 1, it's 1. Minus 1, minus 1. 3, 3. This is possible only for a symmetric matrix. It is symmetric. It's like you can just fold it on this. You can see, superimpose this element with this. They will be exactly identical. This will be your axis of symmetry. That is why it's called symmetric matrix. It's an axis of symmetry. You see, they are same. Don't forget to make that observation. It's very, very important. Okay, now, next one. Look at the skew symmetric matrix. For a skew symmetric matrix, guaranteed your diagonal will always be 0. Guaranteed your diagonal will always be 0 for a skew symmetric matrix. And not only that, the other non-diagonal elements, look at them, they will be of opposite sign. 3 means minus 3. 3 minus 3. 9 minus 9. Skew, it is symmetric. Skew means with a negative sign. So even though the magnitude wise the numbers are same, they only differ algebraically by the sign. So for a skew symmetric matrix, the diagonal element is all 0. Diagonal element is all 0. Only thing is the other elements, they will be numerically equal but algebraically of opposite sign. Whereas here the non-diagonal elements algebraically and numerically they will be equal. This is a very, very, very important observation. Please do not forget this. Now let's continue further. Let's look at this matrix A. This is A. I will take A transpose. What is A transpose? A transpose is 3, 1, 5, minus 1. Interchanging rows and columns, right? Now I want to find P. What is P? Half of A plus A transpose. Correct? Half of A plus A transpose, which is half of What is A plus A transpose? 3 plus 3, 6. 1 plus 5, 6. 5 plus 1, 6. Minus 1, minus 1, minus 2. Now what is P transpose? Half of 6, 6, 6 minus 2, which is nothing but P. Very simple. P is symmetric. And let us examine that interesting property. Look at the diagonal element. It acts like a mirror. Can you see these two elements are equal? Beautiful, isn't it? Next one. What is Q symmetric? Q equal to half of A minus A transpose. I am able to take this and you are able to understand because of the derivation. That's why I feel the derivation is very important for me as far as the understanding is concerned. Now what is A minus A transpose? 3 minus 3 is 0. 5 minus 1, 4. 1 minus 5 minus 4. Minus 1 minus of minus 1 is 0. Now what is Q transpose? Half of 0 minus 4, 4, 0. They don't look similar. So I'll take minus out and check whether everything is okay. Yeah, it's okay. This is nothing but minus Q. So you have proved that Q is skew symmetric. Correct? Now again I want you to observe the diagonal. Look at the diagonal. The diagonal elements are all 0 for a skew symmetric matrix. Don't forget this. And the non-diagonal elements, see, numerically they are equal, algebraically of opposite sign. Now what's the last part? What do you have to do last? I have to find P plus Q, which is half of, what is P? P is 6, 6, 6 minus 2. And what is Q? Half of 0, 4, minus 4, 0. So I keep half outside, add 6 plus 0, 6 plus 4, 6 minus 4, minus 2 plus 0. Now divide by 2. What do you get? 3, 5, 1, minus 1, which is nothing but A. So you have expressed your matrix A as sum of symmetric and skew symmetric matrix. 99%, 90% you can say these type of questions will come for 3 marks at all. Generally, if a teacher is setting the paper, this will be one of the questions that comes to their mind, okay, in matrix. So don't forget this, don't forget to study this, and don't miss out on any of these steps, and don't forget what I told, the observation that I made about symmetric and skew symmetric matrix. Okay, let's continue. If this is an NCERT question, it's a very nice question. Here I assume that alpha is acute, okay. Now A is cos alpha minus sin alpha cos alpha, and it is given A plus A transpose is I have to find. This condition is given to me. So what is A? A plus A transpose is I. So what is A? Cos alpha minus sin alpha and cos alpha. Now what is A transpose? Interchange rows and column. Cos alpha, sin alpha, minus sin alpha, cos alpha. And what is I? It's an identity matrix. 1, 0, 0, 1. Now add. How do you add? This is alpha. I wrote it as X. So this is 2 cos alpha minus sin alpha plus sin alpha is 0, 0, 2 cos alpha equal to 1, 0, 0, 1. So from this, what do you know? 2 cos alpha equal to 1. Cos alpha equal to 1 by 2. Alpha is pi by 3. Since I said alpha is acute, if they don't say anything, you may have to write the general solution. We don't have. Actually, in the NCERT book, it's an MCQ question. I cut down all the options. I just gave the question. Okay. So if you refer to the NCERT book under transpose of a matrix, they have given 4 options, and one of the options is pi by 3. Okay. Let's go to the next question. It's a very, very, very important. Many a times it either comes in your school exam or it will come in the board exam. Very, very famous and very popular question. A and B are symmetric matrix. It's given. So what is given? It's given that A and B are symmetric. If A and B are symmetric, what do you know? A transpose is A and B transpose is B. Now, I want to check whether this is symmetric or skew symmetric. So what I will do, I will consider AB minus BA. If I want to check whether it is symmetric or skew symmetric, what I should do, I should check by taking transpose. Now, how do I take transpose? You all know A minus B whole transpose is A transpose minus B transpose. So look at this entire thing as A and this entire thing as B. So what is that equal to? A transpose, see, this is A transpose minus B transpose, correct? Now you also know that AB whole transpose is B transpose into A transpose, right? So what is AB transpose? B transpose into A transpose. What is BA transpose? A transpose into B transpose, using that result. But you know, from 1, B transpose is B because it is symmetric. A transpose is A, correct? Now here I take minus outside. What do you get? AB minus BA. So what have you proved? You have proved that AB minus BA whole transpose is minus of AB minus BA. That means what you can conclude? AB minus BA is skew symmetric. Okay. I have some more questions to do. I told you this is going to be my last video, but since we already crossed 30 minutes, I don't want to burden you on this. I will put one more video, which will be the last video on matrix, okay, where I will do few more questions on transpose and some more questions on few more that will be beneficial for you, okay, so that I don't want to just complete it without doing those things, okay. I hope this video was very useful to you, okay. Please subscribe to my channel and also press the bell icon for getting notification on further videos. I hope this was very useful. Okay, have a nice day. See you again. Bye bye.